Hi everyone, this is Tom Yang. Welcome to Math at All. Today we'll be talking about complex number, which is a topic that will be included in the AMC 12 exams, but not in AMC 10 or AMC 8 exam. So if you are doing the AMC 12 exam, this video or complex numbers in general might be very helpful for you. So let's get into today's topic, Euler's formula. We're going to talk about Euler's formula today. What is it? The Euler's formula says e to the power of I times theta equals to cosine theta plus I sine theta, where e is the base of the natural logarithm, I is the imaginary unit, so I equals to the square root of negative 1, and theta is the angle in radians, okay? And we're going to prove this formula today step by step using calculus. So to start, we're going to introduce a function called z theta. And I'm going to make it equal to cosine theta plus I sine theta. Okay? And now I'm going to take the derivative of z with respect to theta. Watch what will happen. It will become dz over d theta equals to negative sine theta plus I cosine theta. Correct? Now what should we do? Are we going to isolate theta or do something else? Well, it turns out it's quite hard to actually make theta to the same side because it's very hard to take the integral of that, right? And instead, we're going to do a little trick here. So if you see the z function here, and if you times this function by I, what would you get? Well, I times z, what is that? That is I times cosine theta plus I sine theta. And if you were to expand it, it would be I times cosine theta minus sine theta, correct? Because I squared, I times I is negative 1. And what do you notice? This exactly matches this. So we can sub this in here, which will make the equation turn into dz over d theta equals I times z. See? The equation is much simpler right now. And we're going to now collect like terms and isolate them to each side. So dz over z is equal to I times d theta. And we're going to take the integral on both sides. Well, what is the integral of dz over z? If you're familiar with calculus, then you will know that this is actually equal to ln z plus c equals to I times theta. But what is c here? C is an unknown value that is yet to be solved. Okay, but right now we're trying to isolate c to the other side, and we're just going to have a single z on one side. So we're going to have ln z equals to I times theta minus c. And z will equal to what? Z will equal to e to the power of I times theta minus c. Okay? See? This expression here is quite similar to e to the power of I times theta. But we're not there yet. We're trying to get the value of c here. Okay? So how are we going to do that? Well, again, we're going to use the z function, and we're going to set the value of theta to 0, because why not? Math people always like 0, because it always simplifies things. Well, z0 is actually cosine 0 plus I sine 0, right? Cosine 0 is 1, and sine 0 is 0, so it's 1 plus 0, which results in 1. So, from here, we can say z0 equals to e to the power of I times, e to the power of I times 0 minus c, and z0 is 1. We already calculated here, so 1 equals to e to the power of I times 0 is 0, so e to the power of 0 minus c. Well, e to the what is equal to c? 0, right? E to the power of 0 will equal to 1. And in reality, any number to the power of 0 will equal to 1. So 0 minus c equals to 0. Therefore, c equals 0. And if we were to sub this back in, we would get z equals to e to the power of I times theta minus 0, which is e to the power of I times theta. Now we fully prove this formula. So theta equals to cosine theta plus I sine theta, and z theta also equals to e to the power of I theta. Therefore, e to the power of I times theta equals cosine theta plus I sine theta. Now we prove this formula. Well, I believe there are many other ways to prove this formula, but today we are using calculus. So if you know how to do the proving process in other ways, then good for you. So I think this will end this video today, and thanks for watching. I'll see you next time.